Good afternoon. I'm Evan. I'm the co-founder, CEO of Misten Lab, a one-year-old infrastructure company. So today I'm going to talk about a topic you're probably a little bit sick of, Web3, blockchain. What is that? Unfortunately, you cannot escape. I'm going to tell you a little bit more. So first, let's talk about what exactly is Web3. But even before that, let's talk about what is wrong with the web today that needs fixing. So what has happened in the last few years is the centralization of the content distribution is becoming a bottleneck for a lot of the internet companies, right? Content platforms are the one that squeeze all the profit out of the user-generated content. Social network that ask you to import your contact list, but doesn't let you take your social graph away. So even in games, the asset you have in the games are not valuable, don't have utility outside the private universe. So that is what we're trying to fix today, the essence of Web3. The essence of Web3 is a shift in the relationship between the products and the consumers and the users. And this is about who has ownership, who control the assets on these platforms. So think about this, right? If the content platform, such as Instagram, give the control fully to the creator, what it would look like. If you are using a social network, you build a following, you can take your social graph with you. If you can take Twitter's social graph with you outside of Twitter and have utility for it, wouldn't that be great? Even better, well, simply like everybody play games, right? In the game, if I earn some assets, if I put some effort and money into it, wouldn't I want to have those things to be valuable to me outside the game, right? So the essence of Web3 is that. It's changing the behavior between the users, the creator, and the platform. And Web3 is not a magical money printing machine. It's not even new web. It's not thing new. It is something the technology will just fade in the background, where users have more ownership of the content. And that relationship between the producers and the consumer will change how the product is going to be built in the future. So what is blockchain? What is the role of a blockchain? A blockchain is an old concept in a lot of ways, right? It's based in this kind of technology term called replicated state machine. It's been around for many, many tens of years. But what blockchain is today is essentially infrastructure for programmable assets. So the difference here is you are even more replicated, so you distribute the trust not to a small number of companies or entities. You're trusting a large swaths of validators, and you have shared economic interest in them. So the shared trust, distributed trust, is a major part of the blockchain, and the programmability is what makes it special. Would you rather trust a program or centralized entity? They may not have your best interest in heart. So ultimately, fundamentally, at its core, a blockchain is just a programmable, shared, open, authenticated database for assets. That's the definition of blockchain. And let's look at it. Does it live up to the promises? Because you'll be hearing a lot about this for the last few years, right? All these different blockchains that come to the market. How well are they doing at this core functionality? The first core functionality is how well does it do to let you define assets and let you control ownership and access. Well, let's look at an example. Everybody is probably familiar with Ethereum here, and EVM. What does the EVM data model means in terms of ownership? Well, let's say Alice buys a token called token X. You issue send a transaction to the smart contract and say, please give me, I'm buying one of these tokens. Okay, so what happens? Well, you don't actually have ownership of the token. What is happening is inside the smart contract, there's a private map that say, now Alice has one token. So what happens now as you want to transfer your own asset to someone else, let's say Bob. So send another transaction to the smart contract. So this is something that's already weird, right? I own my own asset, but you tell me I have to talk to the smart contract to even do things like transfer. So because what is happening is the ownership is trapped internal to the smart contract. So even for something as simple as handing your asset to someone else, you don't have control over it. You can't just do it. You are now moving the control for a centralized entity, a company, to a program that's written by somebody. So you cannot lend your asset to someone else, and you cannot store it somewhere else. You cannot have another smart contract that works on asset. You don't really have ownership of your asset in this data model. NFT is something you heard about, some kind of collectible things that everybody's talking about. Well, NFT today is all about ERC 721 standard mostly, and the only thing it contains is a blob, a JSON blob that has a URL pointing to the assets that actually lives elsewhere. So again, what do you own? You don't really own much. The problem with the common blockchain data model is the assets are trapped inside the smart contract. You have very little control over them. If they don't define the utility well, you're stuck with it. You cannot take your asset and run. And programmability is very, very limited because the NFTs is opaque. You don't know what's going on because the actual assets lives elsewhere, outside the chain. And you heard this word used a lot, composability. What exactly is composability? Well, you want to be able to say, I can have a number of smart contracts work on the same asset together. Well, you can't really do that because the assets, again, are not shareable outside the boundary of the smart contract. So, and also, you really don't have asset level composability. You cannot take two arbitrary assets as you would in the real world and combine them and say, here's a new thing. That is just fundamentally impossible with the current blockchains today. So let's talk about programmability. A lot of people here probably heard about Solidity. It's the most popular smart contract language today. Well, remember we established what blockchains are all about. It's about assets. And the programming language, smart contract, is about programs that work on these assets. Well, unfortunately, in Solidity and a lot of other smart contract languages, it doesn't even have the concept what an asset is, right? It's really, really hard to do a lot of basic stuff without making mistake because the language, the vocabulary is just not there. You cannot easily define a new asset type. You have to do some kind of standard. You cannot rewrite transfer assets easily, and you don't have a way to control who can access your assets very easily. And the other responsibility for the blockchain today is how efficiently handle all the transactions, right? If I want to transfer something, if I want to interact with a new smart contract, how quickly can the blockchain handle these transactions? You probably heard about how blockchains are slow and unscalable, so there's like layer 2, and now talk about layer 3. Why is that? Well, it turns out all the blockchain today are using an architecture that's based on a theoretical treatment from the 1990s. It's theoretical for a reason. It's not meant to be designed and implemented. It's called what we call header-line blocking. At every stage of transaction processing, you're waiting for everything to be processed before you move on. This is fundamentally unscalable in architecture. So I'm going to use a few minutes to talk about a new blockchain architecture that my company is building called SUI. It's a fully asset-centric blockchain. So every asset is a typed object. They're composable. So what does that mean? Well, every asset is just an object and has a type, right? So your global storage is a giant map. And the good things about this is all the dependency between the transactions are statically known. You know exactly who goes first, who follows them, what are the dependencies. So you know the causation orders. An asset as a type object, which means you can define, as a programmer, you can define arbitrary type. Here I'm using a contrite example in a game. Well, you can define 9 different characteristics of this game character. Or you can define it to be 10. You can define it to be 20. You can define what is mutable, what's not mutable. This is what asset creation should be about. It's allow the developer to do whatever they want, create whatever they want, their imagination allows them to do. So now you can do composable asset. Taking a simple object and compose with another simple object. In this contrived example, you can mutate asset. You can change them on the fly. Not this current NFTs, which are static. You create them, you mint them, you never change them again. That is what a composable asset's about. So that is what everybody's been talking about and hasn't realized. So let's take a look at example we just shared earlier about buying an asset and transferring an asset. So in this model, you still send a transaction to the smart contract, say, I want to purchase one token. And you get it, the smart contract create one, and send it back to you, the account. You actually own the asset. So now it's very simple when you want to transfer. You don't have to interact with the smart contract anymore. You can just transfer it to another account. Now, because all these assets are typed, you can the type is public. Somebody else can write another smart contract that interact with your object. You're not locked to one thing that's built for limited applications and not expandable. So we also designed a new language called Move. In Move, assets and ownership are first-class citizens, right? There's a first-class concept. We let the technology make sure all the bad things you heard about smart contracts, hacks on the blockchain, let the language define a way. No longer do you have to worry about, can somebody exploit some mistake in the smart contract to duplicate assets out of thin air, to spend the asset multiple ways without, that's illegal. Double spending is just illegal. This cannot happen. You cannot accidentally destroy your asset. All these things need to be defined by the language. The language will prevent them from happening. If you allow foot guns to the developer, they will shoot themselves in the foot. That is just how things has always been. So this is crucial for us to define a new paradigm, new type of programming language to make sure the developer can do everything they want to do, except for the things they don't want to do. This allows digital assets to behave more like physical ones. So you cannot duplicate them, you cannot double spend them, you cannot destroy them by mistake. But everybody only want to know, but is their blockchain fast, right? This seems different and complicated. Is it going to be slower? How is it different on that front? Well, before we talk about scalability and speed, let's talk about what developer actually cares about, right? Because every blockchain out there are saying, well, we have a roadmap for scalability. We're going to be faster in a year, in a few months. But does it actually help the developer? What do the developer actually need? They need to know, they need to have predictability of the cost. Because a blockchain is fundamentally a developer platform. If I'm using this infrastructure, I want to know how much it's going to cost me. Think about what happened recently. If somebody else is doing something on a blockchain, on Ethereum, you've already seen this example, right? A land sale happened, all of a sudden, everybody's transaction fee go up 100x, right? Your noisy neighbor problem. Your neighbor throwing a party is clog up the street. I have no way to control it. As a developer, I don't want to build on this because somebody else is doing something stupid is going to destroy my business. I'm going to go the other direction. What if a blockchain keep the fee just very, very cheap, regardless how congested the blockchain is? Well, guess what? You're just going to lose availability because the attacker is just going to DDoS to death. Because there's no penalty for them to keep on attacking the blockchain. It's always going to be cheap. So these are the wrong model to think about scalability and performance. It's about capacity elasticity. Near term, you need to have the ability to increase capacity to meet demands. Demands are always spiky. It's never constant. It doesn't really matter if I can handle 100 TPS on average. It's going to be a spike that's going to be significantly higher. Can you handle the spike? In the long run, you want to increase capacity to attract more usage, so the demand increases and you drive the cost down. That is the only way to have a sustainable and healthy market. It's by racing to the bottom in terms of fees. So we're leveraging the object-centric data model for scaling. What does this mean? Remember the old blockchains, all the blockchain today are blocks, 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 blocks. It's waiting for everything to be processed at the same time. And before that's done, you cannot do anything else, right? My transaction, I'm handing my asset to someone else. Somehow I have to wait for someone else interacting with smart contract that have nothing to do with me transferring my asset. That just doesn't seem right. So with our blockchain, we leverage the object data model to be able to separate groups of transactions. They're actually related to each other. They're actually in contention for resources. So you only need to order and process a group of transactions. They're actually related. So the best analogy for this is the existing blockchain is sort of like a single lane, right? Regardless where they want to go, all the outputs are written to a global state, a common global state. So you don't really know who are competing with other transactions because it all look like they're writing to the same Merkle tree. So every step of the way, you're waiting for everything to be done before you move on. It's like you're one bus to take everybody from point A to point B. You don't have a way to scale this. In our model, because things are naturally segmented into groups that are related to each other because it's object model, all these transactions that are interacting with this smart contract need to be processed together. All the transactions that's targeting a second smart contract can be processed together. And my own asset, my own NFT, my own asset, if I want to do something with this, has nothing to do with all the other transactions. It can be processed independently. So by having all these groups, then you have all these different workers. You can scale your processing capacity horizontally. You have 5 groups, you can have 5 workers. Now you're busier, you have 20 groups, you just bring on 20 workers. So it's like I bring on as many cars to take as many groups to their distinct destinations. It's a multi-lane approach. And the pipeline is a lot shorter because a lot of bookkeeping things doesn't even need to happen during the critical path. They can be done separately, periodically, asynchronously. We'd love to dive into this in a lot more details, but that will be another day. So that's the conclusion. The existing blockchains are not just useful even if you fix the cost issue, the security issue, the scalability issue, with all these layers of complexity. The data model and what they think about in terms of assets and ownership are fundamentally broken. That doesn't really allow you to have full ownership of your asset. SUI leverage a completely different data model to solve all these problems, and we'll have the fastest and most scalable blockchain. It's about elasticity. It's about the ability to horizontally grow the system to meet any kind of capacity increase. So if you want to learn more, there's plenty of resources online, and I will have a quick plug for my colleagues' economics talk coming up tomorrow. I hope you enjoy this talk. It's great to have you here.